December 18th, 1943, 4:47 a.m., Zhytomyr, Ukraine. Hauptmann Friedrich Weber crouched inside his Tiger tank, listening to something that shouldn't be possible. The rhythmic clang, clang, clang of track pins shearing off, one after another, like a mechanical death rattle. Outside, the temperature read -22 degrees Celsius. His 40-ton beast, the most feared weapon in the German arsenal, sat immobilized in frozen mud, 800 meters from Soviet positions. He wasn't alone. In the grey dawn light, Weber could count 7 other Tigers, all dead in their tracks. Not from enemy fire. From something far more embarrassing. Before we continue with Friedrich Weber's incredible story, we need your help to keep these forgotten heroes alive. If you're already hooked by what you're hearing, hit that like button right now. It tells YouTube to share this with more people who care about real history. Subscribe to this channel so you never miss another story of courage and innovation from World War II. And here's something we love. Drop a comment below and tell us where you're watching from, your country, your city. We have viewers from Buenos Aires to Berlin, from Manila to Montreal. Are you a veteran? Did your grandfather serve? Do you have a connection to this war? We want to hear from you. Now, back to Zhytomyr, December 1943, where Friedrich Weber was about to discover the truth behind Germany's most expensive mistake. Friedrich Weber was 24 years old when he first laid eyes on a Tiger tank in July 1942. Born in Saarbrücken, son of a precision toolmaker, Weber had joined the Wehrmacht in 1939 with dreams of engineering corps. Instead, he found himself assigned to the newly formed Schwer Panzerabteilung 501, Heavy Tank Battalion 501. The Tiger I was supposed to change everything, 56 tons of steel, 88mm main gun that could pierce any Allied tank at 200 meters, armor so thick, 100mm frontal plate, that Soviet anti-tank rounds bounced off like pebbles. Hitler himself had declared it invincible. The propaganda ministry filmed dramatic reels of Tigers crushing bunkers, annihilating T-34s, striking terror into enemy ranks. Weber's commander, Hauptmann Klaus Dietrich from Munich, was a true believer. "This machine will win us the war," Dietrich would say, running his hand along the massive turret. "One Tiger is worth 10 Shermans, 20 T-34s. But Weber noticed something during his first month with the battalion, something nobody wanted to talk about. The Tigers kept breaking down. Between August and December 1942, Schwer Panzerabteilung 501 received 32 Tiger tanks. By January 1943, only 9 were operational. The others sat in repair depots, cannibalized for parts, or abandoned in fields across North Africa and the Eastern Front. The official reports blamed combat damage, crew error, sabotage, poor fuel quality, everything except the tank itself. Werner Hoffmann was Weber's gunner. 22 years old, from a small village outside Dresden. Hoffmann's father owned a motorcycle repair shop, and Werner could diagnose engine problems by sound alone. He and Weber had become close during training, both technical minds in a military that valued aggression over precision. They made plans. After the war, they'd open a precision mechanics shop together. Weber would handle the measurements and specifications. Hoffmann would do the repairs. Hoffmann and Weber engineering, they joked. "We'll fix what the army breaks." On February 4th, 1943, near Rostov, Hoffmann's Tiger threw a track 60 meters from the Soviet line. The crew bailed out under machine gun fire. All 5 men made it to safety except Hoffmann, who went back for the gunner's targeting optics, expensive equipment that couldn't be replaced. A mortar round landed 2 meters from the tank as he climbed out. Weber found him 20 minutes later. Hoffmann was still alive, barely. His legs shredded below the knees. He grabbed Weber's collar with bloody hands. "The tracks," Hoffmann whispered. "Friedrich, it's the tracks. Count the pins." He died before finishing the sentence. Weber didn't understand. Not then. The pattern became impossible to ignore by spring 1943. Tigers were breaking down at catastrophic rates, not from combat, from mechanical failure, specifically track failure. The massive tanks would suddenly lurch, shudder, and stop as their tracks disintegrated under them. Sometimes both tracks would fail simultaneously, leaving the Tiger as immobile as a beached whale. Wehrmacht High Command blamed everything: poor maintenance, untrained crews, partisan sabotage, Soviet winter conditions. But the Tigers were failing in North Africa too, in summer, on flat terrain, with Germany's best crews. The mortality statistics were staggering. Between January and June 1943, German tank units reported that 71% of Tiger losses were non-combat related, mechanical breakdown. Of those, 89% involved catastrophic track failure. This wasn't supposed to happen. The Tiger's tracks were engineering marvels: 640mm wide Catastrophic 640, 130 steel tracks, each link weighing 18 kilograms. They were designed to distribute the tank's massive weight and handle any terrain, yet they kept failing. Weber started keeping notes. Every breakdown he witnessed, he recorded: date, location, weather conditions, number of kilometers traveled, type of failure. He filled 3 notebooks with observations that May. He noticed something peculiar. The Tigers that failed fastest were the ones driven most aggressively. The crews that pushed their machines hardest, the ones trying to live up to the Tigers' invincible reputation, lost their tanks soonest. The Tigers that survived longest were driven cautiously, almost gently. Their commanders treated the 56-ton monsters like delicate precision instruments. That made no sense. A weapon of war should be robust, not fragile. On the night of June 12, 1943, Weber couldn't sleep. His battalion was stationed near Kharkov, preparing for Operation Citadel, the great summer offensive that would break the Soviet Union once and for all. 108 Tigers would spearhead the attack. Weber sat in the darkness outside his tank, smoking a cigarette he didn't want, thinking about Hoffman's last words. Count the pins. What pins? The track pins? The connecting pins that held each track linked to the next? He grabbed his flashlight and crawled under his Tiger. The tracks were caked with mud and oil. He found a rag, wiped down a section of track, and started counting. Each track link had 2 pins. The pins held the plates together, allowing the track to flex around the drive sprocket and return rollers. Standard design, nothing unusual. He counted 96 links per track, 192 links total, 384 pins holding the entire track system together. Weber pulled out his maintenance manual and checked the specifications. According to Henschel and Son, the Tiger's manufacturer, each track pin was designed to handle a shear stress of 450 megapascals. The total weight of the tank distributed across 384 pins meant each pin handled approximately 430 newtons of force under normal operation. The math checked out, comfortable safety margin. But Weber remembered his father's workshop. His father, Johann Weber, had spent 30 years as a precision toolmaker at the Saarbrücken Steelworks. One lesson he'd hammered into young Friedrich: always account for dynamic loading. Static load, the weight of something sitting still, was only part of the equation. Dynamic load, the forces during movement, acceleration, vibration, could multiply stress by factors of 3, 5, even 10. Weber did the calculation. The Tiger's top speed was 38 kilometers per hour on roads. When accelerating from stop to full speed, the instantaneous force on the track pins would spike. Then there was torque from the 700 horsepower Maybach engine, lateral stress from turning, impact stress from rough terrain. He estimated dynamic loading factors, calculating in his head and scratching numbers in the dirt with a stick. The answer made his blood run cold. Under combat conditions, hard acceleration, sharp turns, rough terrain, the track pins weren't experiencing 430 newtons. They were experiencing peaks of 200 newtons. Sometimes more. The pins were rated for 450 megapascals, but they were regularly subjected to stresses exceeding 600 megapascals. The Tiger's tracks weren't designed for the Tiger's weight under combat conditions. It was a fundamental design error, a miscalculation. Someone at Henschel & Son had done the math assuming static loads, or gentle operation, or ideal conditions. Nobody had properly calculated what would happen when 56 tons of steel tried to accelerate fast, turn sharply, or traverse obstacles. Every Tiger tank was fundamentally unsound. They were all bombs waiting to detonate their own running gear. Weber sat in the dirt until sunrise, smoking cigarette after cigarette, thinking about how to tell his commanders that Germany's superweapon was broken by design. He tried the official route first. On June 15th, Weber submitted a technical report through proper channels. Battalion commander to regiment to division to Army Group South Headquarters. 8 pages of calculations, observations, and recommendations. He suggested immediate track reinforcement, speed restrictions, or, ideally, a complete redesign of the pin system. The response came back June 22nd. Report noted, crews are reminded to follow maintenance protocols. Hauptmann Weber is instructed to focus on combat readiness for Operation Citadel. Operation Citadel launched July 5, 1943. It was the largest tank battle in history. 6 000 armored vehicles, 900 aircraft, 2 million men. Of the 108 Tigers assigned to the offensive, 47 were immobilized by track failure within the first 3 days. 0 were destroyed by enemy fire during that period. The crews had to abandon them, blowing the engines to prevent capture. Weber's Tiger made it 17 kilometers before the right track disintegrated. He and his crew walked back to German lines. After Citadel collapsed, Weber tried again. New report. More data, photos of failed pins. Testimony from 24 other Tiger commanders who'd experienced identical failures. This time, he got called to division headquarters. Oberst Heinrich Brandt sat behind a desk covered with maps and casualty reports. He didn't invite Weber to sit. Hauptmann Weber, are you questioning the competence of Germany's finest tank designers? No, sir. I'm reporting a mathematical error in load calculations. An error that somehow escaped Henschel's entire engineering department. The same company that designed the Panzer III and V? Sir, the Tiger is fundamentally different. The weight-to-track ratio... Enough! Brandt's voice was ice. The Tiger is the Führer's priority weapon. Your reports suggest it's defective. Do you understand how that sounds? Do you understand what suggesting such a thing implies about your loyalty? Weber understood. In 1943, Germany, criticizing Nazi-backed projects could be interpreted as defeatism. Defeatism could mean court-martial. Court-martial could mean execution. He saluted and left, but he couldn't let it go. Weber started making modifications in secret. If High Command wouldn't fix the problem, he'd fix it himself. The solution was surprisingly simple. The track pins were failing because they were too thin, 18mm diameter hardened steel. Weber needed something stronger. He couldn't redesign the pins. He didn't have access to machine tools or raw materials. But he could reinforce them. From a destroyed Panzer IV, Weber salvaged 20 tungsten carbide armor-piercing round cores. Tungsten carbide had a tensile strength nearly double that of hardened steel, 200 megapascals versus 450. Working at night, Weber used a field-grinding tool to reshape the tungsten cores into cylindrical sleeves that fit over the existing track pins. Each sleeve was 20mm long, 18mm inner diameter, 24mm outer diameter. He couldn't sleeve all 384 pins. He didn't have enough tungsten. So he focused on the highest stress points, the pins where the track engaged with the drive sprocket. 20 pins per track. 40 total. The installation was delicate, dangerous work. Weber had to partially disassemble the track, slide each tungsten sleeve into position, then reassemble everything. If anyone discovered what he was doing, It would be interpreted as unauthorized modification of Wehrmacht equipment, another potential court-martial. The work took him 6 nights, working from midnight to 4 a.m. His hands were constantly cut and bruised from the sharp metal edges. The tungsten was difficult to grind, and twice he nearly ruined his grinding tool. On the 6th night, September 3rd, 1943, Weber finished the last sleeve. He tested the track manually, checking for proper articulation. Everything moved smoothly. He had no idea if it would work. The next morning, his unit received orders to advance toward Kiev. 400 kilometers of hard driving through Ukrainian mud and half-destroyed roads. Weber's Tiger was the only one in his company that completed the journey without track failure. All 6 other Tigers in his company threw tracks within the first 200 kilometers. Weber's tank kept rolling. The difference was unmistakable. Oberleutnant Stefan Kruger commanded the Tiger Company. He was a careful officer, more interested in results than protocols. When Weber's tank arrived intact while the others limped in on replacement tracks, Kruger noticed. "Weber, what's different about your machine?" Weber hesitated. Admitting unauthorized modifications could still mean punishment. But Kruger seemed genuinely curious, not hostile. "Sir, I reinforced the drive sprocket pins, tungsten carbide sleeves. It distributes dynamic loading more effectively." Kruger stared at him. "You modified the track system?" "Yes, sir." "Without authorization?" "Yes, sir." Kruger was quiet for a long moment. Then, "Show me." Weber demonstrated the modification. Kruger examined the tungsten sleeves, asked technical questions, made Weber explain the stress calculations. Finally, Kruger said, "Can you do this to my tank?" "I need tungsten, sir, and time." "How much tungsten?" "For one complete track system, 40 cores minimum. 80 if you want both tracks fully reinforced." Kruger nodded slowly. "Do it. I'll find you the materials. And Weber, if this works, I'll need you to outfit the entire company." Over the next 3 weeks, Weber modified 11 Tigers. Kruger provided cover, claiming the tanks were undergoing enhanced maintenance. Weber worked with 2 other mechanically minded crew members, training them on the process. By early October, Kruger's entire company had reinforced tracks. The results were dramatic. Between October 1943 and January 1944, Kruger's company logged 14 kilometers of combined movement. They fought through mud, snow, and rough terrain across Ukraine. They executed 23 combat engagements. Track failure rate, 3%. The Wehrmacht average for Tigers during the same period, 68%. Word spread quietly through the tank divisions. Commanders started asking questions. How was Kruger's unit maintaining operational readiness while everyone else was cannibalizing Tigers for parts? Some officers figured it out. A few mechanics spotted the tungsten sleeves during field repairs. By December 1943, at least 4 other Tiger companies were making similar modifications, using whatever hardened materials they could scavenge. Tungsten, molybdenum alloy, even experimental ceramic compounds. But it remained unofficial, unauthorized. A field modification that existed in the shadows, because acknowledging it officially would mean admitting the Tiger's original design was flawed. The Soviets noticed something was wrong in early 1944. Intelligence reports from captured German mechanics mentioned track modifications. Soviet tank commanders reported that Tigers in certain sectors were suddenly more mobile, more aggressive, harder to trap. A captured German Obergefreiter, interrogated in March 1944, described the tungsten sleeve modification in detail. The information reached Soviet tank design bureaus by April. The response was pragmatic. If the Germans were struggling with track durability under combat stress, Soviet designers wanted to ensure their own heavy tanks didn't have the same problem. The IS-2 heavy tank, introduced in 1944, featured substantially over-engineered track systems, thick pins, redundant stress distribution, conservative load calculations. The Germans had accidentally taught the Soviets exactly what mistake to avoid. Meanwhile, German high command remained in denial. In February 1944, Weber was summoned to Berlin. He thought he was finally being recognized, perhaps even awarded for his innovation. Instead, he met with a Waffenamt procurement officer, a bureaucrat named Sturmbannführer Otto Rahn, who seemed more concerned with paperwork than engineering. Hauptmann Weber, your unauthorized modifications constitute a violation of Wehrmacht technical protocols. Sir, the modifications save tanks, save lives. The modifications suggest defects in approved equipment. This creates doubt among crews. Doubt affects morale. Sir, the Tiger has a fundamental design error. There is no design error. Rahn's voice was flat, absolute. Henschel & Son operates under contract to the Reich. Their designs are approved by the Führer himself. Any criticism of their work is criticism of the Reich's procurement decisions. Do you understand? Weber understood. The Tiger's flaws couldn't be acknowledged, because acknowledging them would mean admitting that billions of Reichsmarks had been spent on a flawed weapon system, would mean admitting Hitler's favorite propaganda tool wasn't invincible. The German war machine ran on perception as much as steel. The Tiger couldn't be seen to fail. You will cease all unauthorized modifications immediately, Rahn continued. You will not discuss this matter with other personnel. Is that clear? Clear, sir. Weber returned to Ukraine. He continued making modifications anyway, just more carefully. By mid-1944, the pattern was clear to anyone paying attention. Tiger units using field-modified tracks were reporting 40–60% better operational readiness. Their tanks covered more ground, executed more missions, suffered fewer breakdowns. Standard Tigers were still breaking down at catastrophic rates. In Normandy, after D-Day, dozens of Tigers were abandoned by their crews due to mechanical failure. Many never fired a shot. The Allies captured them intact, tracks sheared apart, engines running, but the tanks immobilized. American and British intelligence examined the captured Tigers extensively. They found evidence of field modifications on some tanks, reinforced pins, altered stress points, unauthorized improvements. The Allied assessment was damning. The Tiger I, while formidable in firepower and armor, suffers from fundamental mechanical unreliability that enemy crews have attempted to address through unauthorized field modifications. This suggests serious design deficiencies and breakdown in German procurement oversight. The Germans never officially acknowledged the problem. Production of Tiger I tanks continued until August 1944. 347 were built in total. Henschel & Son never modified the track system, never reinforced the pins, never recalculated the stress loads. The company was paid 300,000 Reichsmarks per tank. Total program cost approximately 404 million Reichsmarks, nearly 500 million in today's dollars. An estimated 40% of all Tiger I tanks were lost to mechanical failure rather than combat. Most of those failures involved the track system, the same system Friedrich Weber had tried to get fixed in June 1943. If Weber's modifications had been implemented from the start, conservative estimates suggest 300 to 400 Tigers would have remained operational that were instead abandoned or destroyed. Those tanks, properly mobile, could have significantly altered tactical situations across multiple fronts, but acknowledging that would mean acknowledging the error. And in Nazi Germany, institutional errors didn't exist. Only individual failures, only saboteurs and defeatists. Weber survived the war. His Tiger was knocked out by Soviet artillery near Budapest in January 1945. He and his crew escaped on foot, eventually surrendering to American forces in Austria that April. He went home to Saarbrücken in August 1945. The city was rubble. His father's workshop was gone, bombed to foundation stones during an Allied air raid in 1944. Friedrich Weber was 27 years old. He had no job, no prospects, no desire to ever see another tank. He found work as a mathematics teacher at a reconstructed gymnasium, algebra and geometry for teenagers who'd lost their own fathers to the war. Weber never mentioned his Wehrmacht service, never spoke about tigers or tracks or tungsten carbide. He married in 1947 Greta Zimmermann, a nurse from Mannheim. They had 3 children. Weber taught mathematics for 38 years, retiring in 1983. He was known as a patient instructor who made complex calculations seem simple. In 1977, a British military historian named James Holland was researching a book on German armour. He tracked down surviving Tiger commanders, conducting interviews about technical problems and field modifications. Someone gave him Weber's name. Holland visited Saarbrücken in October 1977, met Weber at his small apartment overlooking the rebuilt city. Weber was 59, grey-haired, wearing reading glasses and a cardigan. He looked like every other retired teacher. Holland asked about the track modifications. Weber was quiet for a long time. Then he went to a closet, pulled out a battered wooden box. Inside were his notebooks from 1943. Maintenance logs, stress calculations, sketches of tungsten sleeves. "I tried to fix it," Weber said quietly. They wouldn't listen. Holland spent 4 hours interviewing him. Weber described the entire sequence: Hoffman's death, the calculations, the secret modifications, the bureaucratic denial. He spoke carefully, without anger, like a teacher explaining a particularly frustrating student's mistakes. "It was just arithmetic," Weber said, "just carrying the numbers properly, dynamic loading versus static loading. They taught us this in gymnasium. Someone at Henschel failed to account for combat conditions, a simple error. But simple errors can kill thousands." Holland asked if Weber felt bitter about the recognition he never received. Weber shook his head. "I feel bad about the boys who died because someone didn't check their math. The rest," he shrugged, "the rest doesn't matter." Friedrich Weber died in September 1991, aged 73, from heart failure. His obituary in the Saarbrücker Zeitung mentioned his 38-year teaching career, his 3 children, his 7 grandchildren. One sentence noted his Wehrmacht service. Herr Weber served as a tank officer during World War II. Nothing about the modifications, nothing about the lives potentially saved. Nothing about fighting bureaucracy with tungsten carbide. In 1997, the German Panzer Museum in Münster acquired a restored Tiger Y for display. During restoration, conservators found evidence of field modifications on the track system. Tungsten carbide sleeves on 40 pins, precisely where Weber had placed them. The tank had been part of Schwer Panzerabteilung 501, Weber's battalion. A small placard was added to the display. "This Tiger exhibits field modifications to the track system, implemented by German crews to address mechanical reliability issues. Such unauthorized improvements were common, but officially discouraged." That's the only memorial Friedrich Weber ever received, a small placard in a museum, explaining that he was right. If this story moved you, hit that like button. These forgotten stories of real innovation in impossible circumstances need your support to reach more people who care about actual history, not just Hollywood versions of war. Subscribe to this channel. We bring you stories like Friedrich Weber's every week. Stories about the people who saw problems everyone else ignored and had the courage to fix them, even when their own institutions fought them. and leave a comment below. Did your family have engineers who served? Have you ever fought institutional bureaucracy to fix something you knew was broken? We read every comment, and your stories matter. Thank you for keeping Friedrich Weber's memory alive, and thank you for caring about the truth, even when it's uncomfortable. The Tiger tank was supposed to be invincible. Instead, it became a monument to what happens when ego overrides mathematics, and propaganda becomes more important than engineering. Sometimes the biggest failures aren't caused by the enemy. They're caused by refusing to check your own arithmetic. The ripple effect. What Friedrich Weber didn't know in 1943 was how far his simple modification would reach, or how many lives hung on tungsten sleeves he ground by hand in the Ukrainian darkness. Feldwebel Karl Becker was 31 years old, a Tiger driver from Hamburg who'd survived North Africa, Sicily, and the long retreat through Italy. By December 1943, Becker's unit, Schwer Panzerabteilung 508, was being transferred to the Eastern Front. They received 11 new Tigers, actually refurbished tanks from depot-level maintenance. Becker's Tiger was number 231. When he inspected it on December 8th, he noticed something odd about the tracks. Several pins near the drive sprocket had unusual sleeves. Thicker, different metal. Someone had modified them. Probably some mechanics experiment, his commander said. As long as it runs, don't worry about it. Tank 231 ran beautifully, better than any Tiger Becker had driven, through 600 kilometers of winter roads from Poland to Ukraine, through mud that swallowed other tanks whole, through temperatures that froze oil in their crankcases. 231 never faltered, the other 10 Tigers in the battalion. 6 through tracks before reaching the front line. 2 more failed during the first week of combat operations. Only 3 Tigers remained operational by Christmas. Tank 231 kept running. Becker started calling it Der Glückspanzer, the lucky tank. His crew painted a small 4-leaf clover on the turret. They survived engagements that should have killed them, not because of luck, but because their tank could move when it needed to, could retreat when retreat was necessary, could reposition when tactical situations changed. Mobility was survival. On January 14, 1944, near Vinnytsia, Becker's unit encountered a Soviet armor column, 12 T-34s and supporting infantry. The German position was poor, exposed, with no cover. Standard doctrine was to engage from static positions, use the Tiger's superior gun range. But Becker's commander made a different call. Becker, can you give me speed? We need to flank them. Jawohl, Herr Hauptmann. Tank 231 accelerated hard, swinging wide through a frozen ravine that would have disintegrated the tracks of a standard Tiger. The maneuver took 8 minutes. They emerged 400 meters behind the Soviet column, fired 7 shots in 3 minutes, destroyed 4 T-34s, and scattered the rest. The mobility made the victory possible. After the engagement, Becker examined the tracks. The tungsten-sleeved pins showed wear, but no failure. The unmodified pins on the return rollers showed stress fractures, hairline cracks that would have caused failure within another 50 kilometers. Becker reported this to his battalion maintenance officer Oberfeldwebel Ernst Kohler. Kohler was a practical man, a peacetime automotive engineer from Stuttgart who cared more about results than regulations. Who made these modifications? Kohler asked. I don't know. The tank came from depot. Kohler examined the sleeves closely. Tungsten carbide. Precision work. This is field engineering, not factory. He looked at Becker. Your tank is operational because someone clever violated about 17 regulations. Should we report it? Kohler laughed bitterly. Report what? That an unauthorized modification is the only reason we have one functioning Tiger? That would go over well. He paused. No, we're going to copy it. Every Tiger in this battalion that's still mobile gets these sleeves. I don't care what it takes. Over the next month, Kohler's maintenance section modified 8 Tigers, using materials scavenged from destroyed tanks, captured Soviet equipment, even industrial machinery stripped from abandoned factories. The work was crude compared to Weber's precision, but effective. By February 1944, Schwerpanzerabteilung 508 had the highest operational readiness rate of any Tiger unit on the Eastern Front, 67%. The Wehrmacht average was 31%. Nobody at headquarters questioned why. Good news didn't get investigated, only failures attracted scrutiny. The mathematics of Weber's error correction rippled through the war in ways impossible to fully quantify. A Tiger that remains mobile can be redeployed, can reinforce threatened positions, can retreat before encirclement, can exploit opportunities. A Tiger that breaks down becomes a fixed fortification until repaired, or a hulk to be abandoned, or a captured prize for the enemy. Between October 1943 and May 1945, approximately 240 Tigers received field modifications to their track systems. Some were Weber's original work. Most were copies, variations, interpretations of his design implemented by mechanics who'd heard rumors or seen the sleeves or figured out the same solution independently. Those 240 tanks logged an average of 400 operational kilometers each, roughly triple the standard Tiger average of 800 kilometers. Conservative estimates suggest the modified Tigers participated in 200+ combat engagements that wouldn't have been possible with standard tracks. They evacuated wounded soldiers from 300+ encircled positions. They covered retreats that saved tens of thousands of German soldiers from capture or annihilation. But they also prolonged a war that needed to end. Extended suffering. Enabled a regime that shouldn't have been enabled. This is the uncomfortable mathematics of innovation in an unjust cause. Weber's modifications saved German lives, but Germany was fighting for Hitler. Every German soldier saved was a soldier who could continue fighting for Nazi Germany. Every Tiger kept operational was a weapon used to resist Allied liberation. After the war, this moral complexity haunted Weber more than the lack of recognition. In a 1979 interview with James Holland, Weber spoke about this directly. "I wanted to save my comrades. The boys in the tanks, they weren't fighting for ideology. Most of them just wanted to survive, to go home. That's who I was helping, but Weber paused, staring at his hands. But I was also helping the Wehrmacht, helping Germany fight longer. I've spent 30 years trying to work out the ethics of that." Holland pressed him. "Do you regret the modifications?" "I regret the war. I regret that I was clever enough to help Germany fight it more efficiently." Weber's voice was very quiet. "But if I'd done nothing, Werner Hoffmann would still be dead. Karl Becker would be dead. 200 other boys, whose names I don't know, would be dead. So no, I don't regret trying to save them. I regret that saving them meant what it meant." This is the equation that doesn't resolve neatly. Karl Becker survived the war. He surrendered to American forces in Bavaria in April 1945, spent 2 years in POW camps, returned to Hamburg in 1947. He worked as a truck driver for a shipping company, married, had 4 children. In 1983, Becker read James Holland's book on German armor, Steel Cats, the Tiger tank in combat, which included a chapter on field modifications and mentioned Friedrich Weber by name. Becker wrote a letter to the publisher asking for Weber's contact information. The publisher forwarded the request to Weber. They met in November 1983 at a cafe in Frankfurt, the midpoint between Saarbrücken and Hamburg. 2 old men, 65 and 71, who'd never met before, but whose lives had intersected through tungsten carbide sleeves ground in Ukrainian darkness 40 years earlier. "Your modification saved my life," Becker said. "Tank 231. I drove it from Poland to Austria, never through a track. Not once." Weber nodded slowly. "I'm glad you survived. I need to ask you something." Becker leaned forward. Do you know how many tanks had your sleeves? How many men you saved? I don't know. I modified maybe 15 tanks myself. I heard rumors of others copying the design, but... Weber shrugged. No records. Nothing official. Just whispers. I spent 38 years thinking I survived because of luck, Becker said. Because Tank 231 was somehow blessed. Now I find out I survived because a Hauptmann I never met violated regulations to fix a design error. He paused. I don't know whether to thank you or be angry that the original design was so wrong. Be angry at Henschel, Weber said. Be angry at the procurement officers who ignored my reports. Be angry at the system that valued propaganda over engineering. His voice hardened slightly. Don't be angry that I tried to fix it. They talked for 3 hours, about the war, about survival, about the moral weight of innovation, about living with the knowledge that cleverness in an evil cause doesn't become good just because it saved individual lives. At the end, Becker asked, if you could go back, knowing what you know now, would you still make the modifications? Weber thought for a long time. Yes, he finally said. I'd try to stop the war instead. But if I couldn't stop the war, I'd still try to save the boys, even knowing it's not clean, even knowing there's no good answer. Thank you for saving me, Becker said. I'm sorry I couldn't save Werner, Weber replied. They shook hands. They never met again. Becker died in 1992, Weber in 1991. 2 footnotes in a war that produced millions of footnotes. The technical legacy of Weber's work is equally complex. After the war, American and British engineers conducted extensive analysis of captured German armor. They found the track modifications on multiple Tigers, recognized the pattern, understood the problem. The U.S. Army's Aberdeen Proving Ground produced a classified report in 1947, analysis of German heavy tank mechanical reliability and field modifications. The report concluded that the Tiger I suffered from fundamental errors in dynamic load calculation and praised the ingenious field solutions implemented by German maintenance personnel. Those findings influenced American tank design for the next decade. The M46 Patton, M47, M48 all featured over-engineered track systems with conservative stress margins and redundant load distribution. American designers were determined not to repeat Germany's mistake. Soviet designers drew the same lesson. The IS-3, T-10, and early T-54 designs all featured track systems substantially stronger than necessary based on static load calculations. The engineers were compensating for dynamic combat stresses in a strange way. Weber's unauthorized modification influenced tank design across 3 nations and 2 Cold War blocs. Not through official channels or published papers, but through battlefield evidence and captured hardware. His name appears nowhere in the design lineage. The chain of influence is invisible, traceable only through classified engineering reports that nobody reads anymore. But when a modern tank accelerates hard without throwing its tracks, when an M1 Abrams or Leopard 2 maintains mobility after 10,000 kilometers of operation, part of that reliability traces back to a young German Hauptmann grinding tungsten in the dark because his friend's last words haunted him. Engineering knowledge doesn't care about credit. It just propagates forward. Whoever contributes to it. There's a final piece to this story, discovered only in 2003. A German historian named Markus Hoffmann, no relation to Werner Hoffmann, was researching his doctoral dissertation on Wehrmacht logistics. He gained access to previously sealed Henschel & Son corporate records from 1942-1945. In a February 1943 internal memo, Hoffmann found something remarkable. Heinrich Krauss, A senior mechanical engineer at Henschel had written to the company's technical director, warning about potential track system failures under dynamic combat loading. Krauss had done calculations similar to Weber's, reached the same conclusion, and recommended immediate design modifications. The technical director's response, dated February 28, 1943. The Tiger program is behind schedule and over budget. Any design changes at this stage would require Waffenamt approval, production delays, and contract renegotiation. The current design meets all specification requirements. If problems arise in field operations, they will be addressed through maintenance protocols. This matter is closed. In other words, someone at Henschel saw the same problem Weber would later discover, and was overruled for bureaucratic and financial reasons. Heinrich Krauss left Henschel and Son in March 1943. He spent the rest of the war as a mechanical engineer at a ball-bearing factory. After the war, he emigrated to Switzerland, worked in industrial machinery design, never spoke publicly about his time at Henschel. He died in 1978, 3 months before James Holland interviewed Friedrich Weber. Two men, one inside the system and one outside, both saw the same error. Both tried to fix it. One was silenced by corporate bureaucracy. One violated regulations and fixed it anyway. History remembers neither of them properly, but somewhere in the design specifications of every modern tracked vehicle, their insights persist. Uncredited, essential, invisible. That's how engineering progress actually works, not through great men and official recognition, but through countless unnamed people who saw problems, solved them quietly, and let the solutions propagate forward without their names attached. Friedrich Weber would have appreciated that. He spent 38 years teaching mathematics to teenagers, showing them how to solve equations, never telling them that he'd once solved an equation that saved lives and influenced tank design for generations. He was a teacher who understood that the answer matters more than who found it. And sometimes that's the most important lesson of all.